You hear it everywhere, right? AI is this incredible force that's writing code, making unbelievable art, and just crushing our hardest exams. But what if I told you that hiding underneath all that power, there's a really basic hidden flaw? A blind spot that makes even the smartest AI stumble on things that, a person could spot in a heartbeat. Let's dig into this fascinating gap in AI's thinking. So we're going to look at the surprisingly tough time that these big, large language models have with simple, everyday logic. And this is a really big deal because it goes right to the heart of whether we can actually trust these systems to think, especially when we're starting to rely on them for more and more important stuff.
All right, let's start with a quick brain teaser for you. Take a look at this. If it's sunny, he goes hiking. Today, he hiked. Therefore, it must be sunny. Now, does that sound right? Just think about it for a second. The logic kinda seems to flow, but is it actually solid?
Well, if something in your brain felt a little off about that, you are absolutely correct. It's a classic logical trap, a fallacy. I mean, think about it. He could have gone hiking for a million other reasons, right? Maybe it was cloudy, but perfect hiking weather. Maybe he just needed to get out of the house. The first part of the sentence doesn't rule out any other possibilities.
And here's the wild part. This isn't just a fun little puzzle for us humans. This exact kind of flawed reasoning is a huge stumbling block for some of the most powerful AIs on the planet. They fall for the exact same trap, which shows this pretty serious gap in their ability to reason properly.
So that begs the question, how big of a problem is this really? Well, researchers decided it was time to stop guessing and actually start measuring. And to do that, they had to build the ultimate logic test, specifically for AI.
And what they came up with is something called the fallacies dataset. Honestly, the best way to think about it is like an SAT, but for AI logic. Its whole reason for being is to systematically test how good these models are at sniffing out errors in arguments, from the super obvious to the incredibly tricky.
And let me tell you, this was not some small little project. The scale here is just massive. We're talking 232 different kinds of logical fallacies, which they used to create over 4,600 individual tests. And every single one of them was checked and verified by human experts to make sure the test was tough but fair.
The test basically splits the problems into two big categories. On one side, you have formal fallacies. Think of these as errors in the pure mechanics of the argument. The underlying structure of the logic is just broken, plain and simple. But then you have informal fallacies, and these are way trickier. Here, the problem isn't the structure, it's the content. The reasoning is just weak, or maybe it's irrelevant, or it's based on really flimsy evidence.
Okay, so here's a super simple example of a formal fallacy to make it clear. Since all pigeons are birds, therefore, all birds are pigeons. You see? The structure is just wrong. Just because all A's are part of Group B, that doesn't mean everything in Group B is an A. The logic itself is broken, regardless of what we're talking about. Now let's contrast that with an informal one. Since I had a bruised banana last week, therefore, all bananas are of poor quality. See the difference here? The structure isn't really the issue. The problem is the reasoning is just terrible. You're making this massive generalization based on one single tiny piece of evidence. It's weak.
All right, so the test is built. The questions are all set. It was time to put the most advanced AIs on trial, give them their report card, and just see what happened. And the results, they were pretty revealing.
The results show a pretty clear pecking order. GPT-4 came out on top, spotting the logical errors almost 88% of the time. Llama 2's big model also did pretty well, scoring just over 80%. Now you'll notice, both are way better than just flipping a coin, which would get you 50%. So they definitely have some skill here, but they're still far from perfect.
But this is where the story gets really, really weird. The researchers thought, hey, what if we try to help the AI out? What if we give them a little cheat sheet by telling them the exact definition of the fallacy they're looking for? What happened next was not what anybody expected. For Llama 2, its performance on those tricky informal fallacies didn't just stay the same. It tanked. It dropped by over 31%. No, you heard that right. Giving it the answer key basically made it dramatically worse. It seems like adding that definition just made the whole problem too complicated and confused the AI's reasoning instead of helping it.
So this shocking result really drove home a point. We can't just keep throwing more information at these AIs and hope they get smarter. We might need to change how they learn to think in the first place. And that's exactly what another group of researchers is working on, a totally different and maybe better way to train AI to reason.
Okay,
So traditionally, most AIs are trained using something called outcome supervision. That's on the left. It only cares if the final answer is right or wrong. It's like a math teacher who just looks at the final number and doesn't care how you got there. But on the right, we have this new method, process supervision. This is like the teacher who says, show your work, and gives you points for every single correct step you take along the way.
Now, this is a really big deal because in the AI world, there's this annoying trade-off that everyone talks about. It's called the alignment tax. And it basically means that whenever you try to make an AI safer or more honest or more aligned with our values, you almost always take a hit on its raw performance. Making AI safer has been expensive.
But this is the breakthrough. The researchers discovered that process supervision has a negative alignment tax. In other words, you get the best of both worlds. It's a total win-win. When you train an AI to show its work and reward its reasoning step by step, you don't just make it safer and easier to understand, you actually make it smarter at getting the right answer.
So, what's the big picture here for the future? Well, we're finally starting to see a clear path forward. A way to build AI that doesn't just parrot back information, but can actually reason in a way that we can follow, that we can understand, and ultimately, that we can trust.
So let's just boil this all down. What are the big takeaways? First, even the most elite, top-tier AIs have these really fundamental blind spots when it comes to logic. Second, thanks to work like the fallacies dataset, we actually have the tools now to measure and understand these flaws with real precision. And finally, and this is the hopeful part, changing how we teach AI, focusing on the journey instead of just the destination, might just be the key to everything.
And that leaves us with one last kind of mind-bending question to chew on. For centuries, we've studied human logic with all of its quirks and biases and fallacies. But what happens if we actually succeed in building an AI that is perfectly, truly logical? What will holding up that perfect mirror teach us about ourselves?